So in example 3, they're asking us to write a composition of the two given functions. So in this case, f of x is given to us as x squared, g of x is given to us as 2x plus 3, and we want to find the following. E has us looking at f of g of x, f has us looking at g of f of x, and just like the last video stated, they're not the same, so we have to do them and treat them both separately. So in letter E, the first thing I'm going to do is I'm going to keep the same function on the outside, which is f, that's given to us on the left. Inside, I'm going to plug in and replace g of x with what g of x is actually equal to, which is 2x plus 3. So in this case, I go back to f of x, which is x squared, and I'm going to plug this whole thing in to my x squared. So I get where my x is, I'm going to plug in the whole 2x plus 3, raise the whole thing to the second power. We all know that this expanded means 2x plus 3 times 2x plus 3, which is calling for us to FOIL. And if we FOIL, 2x times 2x gives us 4x squared, 2x times 3 is 6x, plus 3 times 2x, which is 6x, 6x plus 6x gives us 12x, and 3 times 3 gives us 9. So our new function is 4x squared plus 12x plus 9. The next one in letter F, g is our function on the outside. I'm going to replace the entire inside with my f of x, which is x squared, which means wherever I see an x, I'm going to plug in x squared. So I get 2 times x plus 3. In for x, I'm putting x squared. I'm only distributing the 2 to this one guy, this x squared here, which gives me 2x squared plus 3 as my final answer. Again, I can look at it and see that these two, f of g of x and g of f of x, are not equal to each other. They give us two completely different functions when we take these operations and simplify them. Lastly, in letter G, they're asking for the domain of each composition. But again, we have to look, before we can figure out the domain of the compositions, we have to look at the domains of each of the functions individually. So the domain of f of x, I can plug in positive, negative, and zeros and it works, so I know it's going to be all reals. My domain for g of x, I can plug in positive, negatives, and zeros, so I get all reals for that. Therefore, my domain for f of g of x, I'm not dealing with any division here, so I know that that's going to be all reals for my domain. And my domain for g of f of x, I'm not dealing with division here as well, I'm dealing with all reals for my domain for that composition. So that gets you through letter G. Let's quickly look at example 4 before you start the Now You Tries numbers 4 through 7. In this last example, they want us to evaluate the composition f of g of 2. Alright, so in this case, you know you have to evaluate. Evaluate means solve. You should be getting a final answer at the very end. So the first thing we're going to do to figure this out is, because in order for us to plug this in, we need to know what g of 2 is. Because to take that value and plug it into f, they want us to know what g of 2 is. So since we're trying to find f of g of 2, it makes sense that we find g of 2 first. So that's going to be our first step. We're going to find out what is g of 2. Well, our g function is 5 times x. If 2 is our x value we're plugging in, therefore we're taking 2 and we're plugging it in for x, which gives us 10 for g of 2. Our second step, if g of 2 is equal to 10, then we're actually looking for f of 10, because we're taking the value we got for g of 2 and we're plugging it in. So f of g of 2 is the same thing as f of 10, because we're plugging in that answer for x. F is x squared plus 3. Wherever you see an x for f, in your f function, you're plugging in 10. So x, we're going to replace it with 10 squared plus 3, which we know 10 squared is 100 plus 3. So f of g of 2 is equal to 103. And that's our final answer. You know you evaluated it when you got it all the way down and you solved it and you got a final answer. Now you try numbers 4 through 7, numbers 1 through 3 as well, where we do the next time we get together for class, so make sure you have those done. You can come see me early in the morning if you have questions. Otherwise, I will see you at our next class meeting.